Hi everyone, welcome back to the channel. So today we are going to discuss artificial intelligence Turing machine's most important MCQs. So all these are basic questions that will help you check your knowledge about this particular topic. So students, in this series, this is our lecture number 16. If you haven't watched previous 15 lectures, you can definitely check the description box. I have already added the link there. So now let's just start the session. So here we have the question number 1 that says a technique that was developed to determine whether a machine could or could not demonstrate the artificial intelligence is known as what? So this is the direct definition of your Turing test. Okay, that is your option number 2. It says Turing test is basically a technique that was developed to determine, that helps us to determine whether any artificial intelligence based machine could or could not demonstrate the AI is the Turing machine, Turing test. Here I have added some important points related to this particular topic. So in the year 1950, mathematician and computing pioneer Alan Turing introduced a test that is called a Turing test that helps to determine whether machine can think like human or not. We have already discussed in lecture number 14 and 15 about Turing test and Turing machine. So it is basically a test that helps us to determine whether a machine that we have created can think like humans or not, which means it can demonstrate intelligence. That is your Turing test. All right, this test is very important. It was based on the imitation game. So this term is also very important. So they can ask this question in your examination. Turing test is based on what type of game and modifications? So your answer can be, it was based on imitation game with some modifications. Also, this technique is still a measure of various successful AI projects with some updations. Right? So this is very important statement. Next question we have is a Turing machine that is able to simulate other Turing machine. Let's say we have one Turing machine and this Turing machine helps us to simulate another Turing machine. It is called nested Turing machines, universal Turing machines, counter Turing machines, or none of the above. So the correct answer can be your option number 2. Whenever one machine helps us to simulate another same type of machine, then it is called universal Turing machine. Next question. Which of the following a Turing machine does not consist of? So we have already discussed about some important parts of Turing machine. Here they have asked about which does not consist of, right? So first is your input tape, another is head, another is state register, or none of the mention. So the correct answer can be your option number 4, that is none of the mention. That means input tape, head and state register of your Turing machine, a state register, are the part of Turing machine, right? As you can see here, its explanation, here is its explanation. A state register is one, this is very important. A state register is one which stores the state of Turing machine. It is a register that helps to store the state of a Turing machine and one of the finitely many. Among these is the special start state with which the state register is initialized. Okay. Another question is also very important and easy. It says the value of n if Turing machine is defined using n tuples. What is the value of n if we are using n tuples in Turing machine? So students, its answer is 7. Now let me explain this. So in Turing machine, there are always 7 tuples. You have to remember this point. Okay? That we can write it as Q, S, G. It is a small d. It is Q, O, B and F. Okay. Q means what? Q means the finite set of states of finite control. It is what? It is a finite set of states of finite control. Another is S. It is finite set of input symbols. Finite set of input symbols. Another is your capital G. It is a complete set of tape symbols. Another is your small d. It is nothing but the transition function. Another is Q naught. It is the start state. It is the start state and a member of Q. It is nothing but a member of Q in which the finite control is found initially. Here, the finite set of states of finite control was found. So, it is related to Q naught. Next is your capital B. It is nothing but a blank symbol. Right? Next is your F. It is a set of final or accepting state. It is a subset of Q. It is a subset of Q. Okay, so all these are the value of n. All these are the value of n. Okay, in n tuples, in 7 tuples. Next question. It is a direct or basic question. We have given a statement. Instantaneous descriptions can be designed for a Turing machine. Is it true or false? Instantaneous descriptions can be designed for Turing machine is absolutely true statement. Why? Because in order to describe formally what a Turing machine does, if we want to describe anything that our Turing machine does previously, we need to develop a notation for configuration or instantaneous descriptions, that is called its IDs. All right. Another is, which of the following are the models equivalent to Turing machine? So we have some models that are equivalent to Turing machine in the terms of their working, etc. So first option is multi-tape Turing machine. Another is multi-track Turing machine. Next is register machine and all of the above. So correct answer is all of the above. That means we can say there are 3 equivalent models of Turing machine and these 3 are their names. So you have to remember all these names. Next is halting state of Turing machine are what? So halting state, whenever our Turing machine comes under the halting state, then it means start and stop, accept or reject, start and reject, or reject and allow. The correct answer will be your accept and reject. Halting state means we can accept or we can reject the condition. Which of the following is an extension to the basic model of Turing machine? Here we have the Turing machine. What is its basic extension? Multi-tape Turing machine, multi-head Turing machine, non-deterministic Turing machine, or all of the above? The correct answer is all of the above. So all these 3 are nothing but the extension of basic model of Turing machine. So you have to remember this term, basic model of Turing machine. All right. Why Turing machine is more powerful than finite automata? So in theory of computation, we have already discussed all about finite automata, and we all know Turing machine is more powerful than finite automata. Though, so they are asking about the reason. Option 1 says a Turing machine head movement is continued to one direction. Turing machine ka head movement is always on one direction. That is why it is powerful? No. Its head moves in both the directions. No. Another is Turing machine has capability. Obviously, we have one and 2 wrong options. So option number 4 cannot be your correct option. So we have left with option number 3, that is Turing machine has capability to remember arbitrary long sequence of input strings. Whatever values, whatever input we give to your Turing machine, it has the capability to remember all the long sequences for a long time. That is why Turing machines are more powerful. Turing machines are mostly used when we compare them with finite automata. Last question for today's session is, Universal Turing Machine, that is UTM, influenced the concept of computability, obviously, interpretive implementation of programming language. Program and data is in the same memory. All right, so all these 10 questions are very important. I hope every concept is clear to you. If you have any doubt, you can comment below. And students, if you want me to continue this series with more and more questions, so you can definitely comment. I will surely focus on that. So thank you so much.